Welcome everyone to today's Explainer. I'm absolutely thrilled to have you here. Today we're taking a magnifying glass to one of the undisputed powerhouses of modern tech, Python. Whether you're a seasoned developer, a data enthusiast, or honestly just someone curious about the digital architecture of our world, you've definitely heard of this language. I mean, it's literally everywhere. And today we're going to break down its anatomy step by step to figure out exactly how it works and why it matters so much.
Which brings us to the big hook for today. Why is Python everywhere? From the web apps you browse every single day to massive data science models predicting global trends, right down to the artificial intelligence that's actively shaping our future, Python is right there. It's the invisible engine running the show. So, in this explainer, we're going to reverse engineer exactly why that is, using our source material to give you the ultimate breakdown. Here's our roadmap for today. We'll start with what is Python, then hit its origin story, look at its key traits, dive into pros, cons, and comparisons, and finally wrap up with real-world applications. Let's jump right in.
Section 1. What is Python? Defining the language.
The classic definition goes like this. Python is a popular, high-level interpreted programming language known for its simplicity and readability. Okay, let's instantly translate that technical jargon, right? High level basically means it abstracts away all the really complex machine code, bringing it much closer to actual human language. And interpreted? Well, that just means it executes code line by line without needing a compiler. You write a line of code, the interpreter reads it, and boom, it acts on it immediately. This makes testing and writing code incredibly fast and honestly just super fluid.
Section 2. Origin story. From 1989 to modern day.
Let's take a look at this timeline. You know, Python wasn't born in some massive corporate boardroom. Actually, it was created back in 1989 by Guido van Rossum at CWI over in the Netherlands. Fast forward a bit to 1991, and version 0.9.0 drops, and it already included core features like classes and functions. Then, in the year 2000, Python 2.0 hits the scene. That brought in crucial structural elements like list comprehensions and garbage collection, which, by the way, automatically frees up memory for you. And then 2008 happens. Python 3.0 is released. This was a huge milestone that dramatically improved the language constructs and brought much better Unicode support. So as you can see, it's been this really steady, deliberate climb to the top.
Section 3. Key traits. Let's look at Python's DNA.
Now, what's truly a superpower here is Python's sheer accessibility. I mean, its syntax actually reads like English. When you look at Python code, it's just clear and readable, which dramatically reduces the learning curve for beginners. Plus, it's cross-platform. The exact same code runs on Windows, Mac, and Linux. No problem. It also comes packed with this massive standard library, so you really don't have to reinvent the wheel for every single task. And another huge superpower here is that it's dynamically typed. So what does that mean? It means developers don't need to explicitly declare variable types when writing their code. The language just naturally figures it out on the fly.
But hey, every Titan has its kryptonite, right? And it's absolutely crucial to understand the trade-offs here. The dynamic, easy-to-read nature of Python, it requires a compromise. Because it's interpreted line by line and dynamically typed, it does suffer from slower execution speeds compared to compiled languages like C++. It also has pretty high memory consumption. Furthermore, it's generally considered less than ideal for mobile app development. And for the advanced developers watching, our source notes the GIL, or Global Interpreter Lock. That essentially limits Python's performance in true multi-threaded environments. Basically, it can struggle a bit to do many heavy tasks simultaneously.
Moving on to Section 4. Pros, cons, and comparisons. The matchup.
And this perfectly illustrates the balance we've been talking about. On one side of the scale, we have Python, firmly grounded in its simpler syntax and dynamic nature. And on the other side, we have languages like C++ and JavaScript. It really captures the core programming trade-off. You're constantly weighing simplicity and ease of use against raw execution speed and hardware control.
So the crucial point is really this. Developers choose Python to maximize the speed of writing code and the ease of reading it. If you need to build something fast, prototype an idea, or process data without constantly fighting the syntax, Python is your absolute winner. But say you're building a highly intensive mobile application or a graphics-heavy game where literally every single microsecond of execution speed matters. Well, then you turn to other languages that are statically typed and offer more direct control over memory usage. It's really not about which language is objectively better. It's entirely about choosing the right tool for the job.
Section 5. Real-world applications. What it builds.
So, what does it build?
Well, the answer is kind of almost everything. Python dominates some incredibly diverse fields.
It's a cornerstone in web development, the absolute gold standard in data science, the driving force behind artificial intelligence and machine learning, your go-to for daily automation and scripting, and yeah, it even has a footprint in game development. Its extensive libraries just make it a profoundly versatile tool for pretty much any modern tech problem you can think of.
Let's dive a little deeper and see how this actually builds our digital infrastructure, specifically in web and data. Starting with web development, Python acts as the backbone using frameworks like Django and Flask. Our source highlights that Flask is lightweight and incredibly easy for setting up simple web apps or APIs really quickly. Django, on the other hand, is this robust, high-level framework designed to handle large, scalable web applications with built-in admin panels. Then, pivoting over to data science, Python uses libraries like NumPy for super-efficient numerical operations and multi-dimensional arrays, while Pandas sits right on top of that to allow for deep data manipulation. We're talking sorting and filtering massive tables of structured data with ease.
But beyond web and data, Python truly solidifies its place at the absolute cutting edge of human technology, artificial intelligence. It's the language of choice for creating machine learning models and AI algorithms, utilizing these immensely powerful libraries like TensorFlow, Keras, and Scikit-learn. And on a much more day-to-day level, it's the premier language for automation. It takes those boring, repetitive tasks, scripts them out, and schedules them so computers can do the heavy lifting while we humans actually focus on creative problem solving.
As we wrap up this explainer, we're left with a pretty fascinating reality. Python intentionally and extremely successfully traded raw execution speed for human readability. It basically bet on the idea that making code accessible, readable, and simple to write would empower millions of people to build incredible things. And from automated scripts to the massive AI models changing our society today, that bet paid off. But it does make you wonder, as computing power just continues to grow, constantly reducing the sting of Python's slower execution speeds, will this relentless focus on simplicity continue to rule the future of technology, or will the next big evolution of coding look completely different? Thank you